All right, welcome back. And I got the first of two examples to finish off the note. What's the force of attraction between a 70 kilogram person and a 2,000 kilogram car when they're 10 meters apart? You can see it's just decoding at this point. You know that you are using two objects, so that means you need to use this formula. It's the only one that includes two masses. If it was just the force of gravity acting on one, then it might be F equals ma, but in this case we're looking at the attraction between two objects. So going through and applying the formula, 70, 2,000, and 10 squared. We go ahead and do the calculation. We find that we get 9.34 times 10 to the negative 8 newtons, and I'm going to write this out just to emphasize what that is. So that's 0.1236 7934 newtons. That's how small the force of attraction is between you and a car when you walk by. A 70 kilogram person, that's approximately 150 pounds. So let's call that an average person. That is a pretty negligible force to actually feel that attraction. So therefore, a person would feel, so very, very small, 9.34 times 10 to the negative 8 newtons. All right. Final example then. What happens if we have a 5,000 kilogram satellite and it's in orbit, 40,000 kilometers above the Earth's surface? Radius of the Earth is 6,400 kilometers. Determine the weight of the satellite while in orbit. Determine the weight. So we're looking at its force due to gravity. So force due to gravity would equal gravitational constant, m1, m2 over the r squared. So 6.67 times 10 to the negative 11. Mass of the Earth, this I don't have it handy, to be quite honest. So I think it's 5.98 times 10 to the 24th. Might want to just put a star on that and ask me the next day to make sure that's correct. It's probably when I do this from memory. And 5,000 kilograms divided by, and this is where a lot of people, you got to remember, A, it's got to be in meters, and B, you need to make sure that that you add the radius and orbit together because it's to the center of each object. So easiest way to do that, 6,400 kilometers. So I'm going to put square brackets in here. I'm going to add it in terms of kilometers. 6,400 plus 40,000. Okay. Now kilometers, if I go times 10 to the 3, that then makes it meters. So I'm just playing with scientific notation there. And I'm all set. So I can actually punch that in as is into the calculator. So if I do that, I get an answer of 926 newtons. And that seems about correct if I recall. So therefore, the satellite will weigh 926 newtons. So there we are. So a couple of things, a couple of components you need to remember here. First one, when you're given kilometers, and that's a couple of the questions are like that, you convert to meters. The conversion is just do it in scientific notation times 10 to the 3, and that'll take care of it. The second one, again, make sure all your masses are in kilograms. I think for the most part they are in the homework. So homework's listed down here. If you have any questions, let me know in class, and we'll try to get them straightened out. But you're just using that FG formula, and you want to make sure, again, if you don't already have it written down, make sure it is on that study sheet or cheat sheet for future tests. All right, so we'll see you in class.